a word problem that has different units for the same item, same type, that's something that you have to really be careful about. So let's look at the units here. Here it says minutes. Minutes is the units of time, unit of time, and then that's again unit of time, right? Okay, now this one has 10 miles per hour. Miles is a unit of distance. Hour is a unit of time. Miles per hour is a unit of speed, right? Okay, so which unit is like two different units for the same type? Yes?
You have to make the minutes into hours.
Yes, so we have both minutes and hours being used for measurement of time, right? So we better change the minutes into hours. Okay, so how do you change 30 minutes into hours? 30 minutes is, in terms of hours, what is that? Half an hour. So you can use 0.5 or 1/2. I realize that for this question it's better to use 1/2 hour. Okay. Then what about 10 minutes?
1/6 of an hour.
Huh? 1/6 of an hour, right? Because, I mean, if you play the game that takes you 10 minutes, how many times can you play in 1 hour? 6 times, so it's 1 out of 6, right? So 10 minutes would be 1/6 of an hour. Okay, once you replace those numbers accordingly, now it's safe to approach. Okay, the word problem that you're seeing right now is a speed, distance, time type of question. And you need to know the very basic relationship between speed, distance, and time. What is it? What's the equation between those three?
Speed equals distance over time.
Speed is distance over time, right? Now, you don't necessarily have to memorize that because think about the following. Everyone knows that if you're driving on a highway, the speed limit is in terms of what? Miles per hour, right? So if you see something like 10 miles per hour, that means is 10 miles, per means divide, and it's hours. Right? That's the way a speed is measured, right? And this basically is saying that if you drive 10 miles in 1 hour, let's say it's a heavy traffic, so you're going really slow, if it's then your average speed will be 10 miles divided by 1 hour, and that's the speed that you have. Okay, so this very unit for the speed suggests that we have the relationship speed equals to distance over time. All right. Now, let's think about the following. Well, first, I'm going to rewrite this as S equals to D over T because that's easier. Now, however, when you solve these questions, often it's better to have this equation solved for D and also for T. So let's solve for D. How do you solve for D? Multiply by T both sides. So if I multiply by T both sides, say I put T here and then T there, then I have distance equals to time times speed. Okay? And then, so we have an equation for S. We have an equation for D. Now, we need an equation for time. So how do you solve this for time? Divide by S, right? So you have T equals to distance over speed. All right, so you have those three fundamental equations. you should be writing down before you approach word problems. If you see a word problem that's using speed, distance, time, just write these three equations down. And you don't have to memorize it. All you have to remind yourself is miles per hour. That's the only thing you have to remind yourself. That automatically says speed is distance over time, and then you can just keep solving for one of them, and then you get these three equations. So that's not hard, right? Okay, but then how do you tackle such a question? There are many ways to tackle such a question, but the most effective one is to make a table. So we're going to make a table. We're going to make a table with distance, time, and speed. And it doesn't have to be in this order. You can mix them up, but just clearly label it so that you know which is which. If you don't label it, then you wouldn't know what to do. And then read the question. Usually you have 2 or 3 scenarios. So in here you have 2 scenarios. What are those 2? One is going to the work, and the other is returning, right? So there's the going to work and then coming back from work. Okay? So those are the 2. And then you're going to just ask the question whether you know distance, time, or speed, and just introduce variables if you don't know. Okay, so first, going to. Do you know how far the workplace is from home? So what do we do? Put an X. Just put an X right there. Okay, how about time? Half hour. 30 minutes. So we decided to put 1 hour for that one. Okay, what about the speed? Do we know the speed when he's driving to work?
More than the afternoon.
Yeah, something like that, but that's not clear, right? We don't know. So what should we do? Y this time, because that's different from X, right? So you have another unknown. So we have 2 unknowns. Now, when you introduce unknowns, you have to be a bit conservative. You don't want to introduce too many. Since we have 2 equations coming from this and this, probably what you want is you want to limit yourself to just 2 unknowns. Okay? You don't want more than 2 unknowns. And in many of the word problems for speed, distance, and time, you just need at most 2, 1 or 2. That's how it works. And rarely you get to 3, so just try to limit that. Okay, now coming back. What's the distance coming back? It's unknown, however, we know something about coming back. It says using the same route, right? So what does that mean? It's the same X. These 2 should be the same. If you introduce Z, then you're not using that information that these 2 are the same, then you won't be able to solve, right? Okay, how about the time?
4, 6, 7 hours.
So 40 minutes.
Right, it took 40 minutes, right? 30 minutes plus 10.
2:30.
So it's 40 minutes, which is 40 out of 60 hours, right? And you can cancel the zeros out, and 4 out of 6, which is 2/3 hours, right? And make sure your unit is in terms of 2/3. Another way to get the same answer would be, it's 1/6 hour more than 1/2, right? So you can do 1/2 plus 1/6, which is 3/6 plus 1/6, which is 4/6. Again, same thing, 2/3 hours. So either way, you get 2/3 there. Okay, now what about this one? Y plus?
Or
Y minus.
Y minus 10, right? It's slower. So the speed is slower by 10 miles per hour. So we write it like that. Okay, so we built a table. We don't have more than 2 unknowns. So that's great. We can solve this. So let's actually solve it. Now, we're free to choose, in this case, we're free to choose any one of these three equations, but the one that I favor most is this one. Why do you think so? Because it's not a fraction. The other ones are fractions, so I don't like them. So let's use that, which says, so if I use d equals to time times speed, this would be x equals to 1/2 times y, and this would be x equals to 2/3 times y minus 10, and you have to be careful. If I just write this, I'm wrong. What am I missing? You need a parenthesis because 2/3 is being multiplied to the entire thing, okay? All right, so we have a system of equations. We have two equations and two unknowns. Perfect, that means you can solve it, okay? If you have two equations and three unknowns, then something's not right. You have to find an extra equation, right? But two equations with two unknowns, that means we can solve it. How do you solve a system of equations? All you have to do is just take one and plug it into the next, right? Now, sometimes you can't, so you have to first solve for one variable, and then you plug into the next. But luckily for us, the first equation is already solved for x, right? So that means I can just replace this x by 1/2 y. Let's continue. 1/2 y is equal to 2/3 y minus 10. Okay, how should we solve this? Give me suggestions. Yes?
Do you want to get both of the y's to the same side of the...
That's one. Eventually, that's what you want to. Yes.
Distribute the 2/3 to the y minus 10.
That's another possibility. You can multiply 2/3 here. Any other suggestions? Yes.
Divide by 2/3 of its
No. Let's see. No, that's not going to be that useful. It will just make. Yes.
What if you multiply both sides by 2?
Not 2, but not 3, but
Consider variance.
no.
Oh,
See, you know how I hate fractions so much, right? And so you do. So do you, right? Yeah. So we want to get rid of these denominators. How do you do that? Multiply both sides by 3 and 2. So what do you multiply at the end? You multiply by? No. You okay. I'm not getting the point. You multiply by 2 to get rid of this 2, right? But I need to get rid of this 3. So what do I multiply by? 3 as well. So that's same thing as multiplying by 6. That's the answer I wanted. Okay? If you do that, then the denominators disappear. So this 2 is going to cancel that one, leaving you with 3. So we'll get 3y. And then over here, this 3 is going to cancel with this 3, leaving you with 2. But 2 times 2 is 4. You get 4 times y minus 10. Okay? Now what? You multiply by 4. So I'm just following the suggestions other people gave. It's just that I'm much happier because I don't have any fractions to worry about. Okay, I'm going to subtract 3y both sides. So that's going to be 0. 4y minus 3y, what's that? What? Just y minus 40. So what's the solution? Y equals to 40. Okay. What's the unit for y?
miles per hour.
Right. Y was speed, and the speed in the work problem was measured as miles per hour. There's 40 miles per hour. Is that the answer? No. Why?
It's asking for distance
It's asking for distance. Okay, so how do you convert this to distance?
divided by the time.
How do you get the distance? Distance is
Or multiplied by
time times speed. So you multiply 40 by half an hour. Okay. Or you could just have looked at here. See, we're looking for the distance, right? We're looking for x, and x is 1/2 y, so you can say x is now 1/2 times y, which is 40, and what's that? It's 20 miles per hour. No, miles, just miles. Okay? So that's, again, let's write down the fundamental equations. speed is what over what? Distance over time. And if you multiply t both sides, you get distance equals to time times speed. And then if you solve for time, you get time equals to distance over speed. Doesn't take long, you can do it really fast. Okay, so once you have this now, you have going to and back, distance, time, and then speed. Okay, so what do we know about the distance? Nothing, so we put x. How about the time going? 3.6. Speed? We don't know, so again we put y. Distance? Unknown, but we do know that they're the same. Okay, coming back, you're driving the same distance. And then time? 4. And speed? Because she was driving 5 miles slower, so it's y minus 5. Okay, let's apply this distance equals to time times speed. So this is going to be x equals to 3.6 y. And this is going to be x equals to 4 times y minus 5. And then this is an equation, this is a system of equations, and you're supposed to solve for one variable and plug that into the next one. However, we already have this solved for x. X is this, so it's very convenient for us. We can just plug this in here and you get 3.6y equals to 4 times y minus 5. Now, if you really don't like decimals, one option is to multiply by 10 both sides. But I don't think you don't have to be that extreme. So let's just multiply and try to subtract. So you have 3.6y equals to 4y. 4 times 5 is 20. So that's what you get. What should I do next? Subtract. Okay, so one way is to subtract 4y. I like subtracting smaller numbers. That's easier for me. So I'll subtract 3.6y so that the left side is 0. The right side is, what's 4 minus 3.6? 0.4. And then minus 20. Move this 20 to the other side. Or add 20 to both sides. Either way, you get 20 equals to 0.4y, which means that you can divide by 0.4, right? So you have 20 equals to 0.4, 20 over 0.4 equals to y. Now the question is, how do you compute 20 over 0.4? Let's say you don't have a calculator. How do you compute it without a calculator? Yes, you multiply 10 top and bottom, and that gives you 200 over 0.4 times 10, so it says 4, right? Yeah. And then you just have to do 200 divided by 4. 4 times 5 is 20, and then there's a 0 here. So you know that y must be 50, what's the unit? Miles per hour. Is that the answer?
Yeah.
Yes, this time it is, because what was the question?
How
How fast was she driving to mom's house? So it was asking for really this one. That was the question, and we found the y. Right?
Unless it's on Sunday. So when back on Sunday, you take away 5, it's 45 miles per hour.
Oh, did the one on here was saying Sunday?
Yes, sir.
Oh, okay. So I kind of like shortened this. I see. So in the paper it was saying, actually asking for this speed. Okay. So I solved a slightly different question than the paper. Yeah. Then you're right. If you're solving the one that's on the paper, it will be 50 minus 5, 40 minus 5, 45.